Hello everyone, my name is Josh Taylor. Today I'll be presenting my research proposal on the structural integrity and degradation of 3D printed cost-effective PLA prosthetics. In this proposed research, we'll be assessing the structural integrity and degradation of PLA in 3D printed medical devices to address the need for a cost-effective solution for prosthetics. Now, you might be wondering, why is this so important? Investigating this question is quite crucial due to the estimated 4 to 6 million mines and other unexploded ordnances in Cambodia, resulting in over 25,000 amputees. Now, while modern prosthetics do exist, they are quite costly, and only 5 to 15% of low-income countries have access to these assistive medical devices. Missing limbs can lead to a feeling of incompleteness and social exclusion, while these proposed 3D printed prosthetics can help individuals integrate back into society. Now, accompanying the dot points I've provided a mind map, which sums up all the potential benefits in the validation of PLA prosthetics. Not only would it address the social inclusion, its ease of access and low entry skill requirement could lead to large scalability and rapid manufacturing to aid an ever so rising targeted audience. Now, how we would go at this. As you can see in the slide, I've broken down the methodology into primarily 3 research methods, which will be used. These will include the experimentation, the surveying, and the observations. I will be using controlled experiments and FEA simulations to compare printing parameters and model orientation effects on PLA prosthetics, following the ISO 527 standards for plastic material testing. A makeshift rig will measure the cyclic motion and degradation of the prosthetic during use. We'll also be surveying leading filament manufacturers and other 3D printer retailers, which will provide insights on material properties and printing parameters. The physical prototypes will undergo stress testing to identify any concerns, including effects on ambient temperature and additive manufacturing challenges. Now, the resources I will require for this research include access to CAD modeling software, an FDM printer, either a bed slinger or a Core XE-driven 3D printer, an FEA software, ANSYS or any other alternative will suffice, a testing compression and tensile rig which will need to be developed for the ISO 527 testing, as well as to develop observations on the printed prosthetics. And finally, we will need financial backing from stakeholders and other investors to cover material costs and the development process in sourcing equipment, building the test rig, and other minor expenses. Now, at the outcome of this project, I aim to achieve several potential outcomes. The design optimization and development of cost-effective PLA prosthetics while maintaining acceptable durability levels, the validation of FDM prosthetics as a cost-effective alternative to traditional methods for treating amputees, material insight into PLA filaments and blends to understand their effects on medical devices, as well as finally the performance evaluation of 3D printed PLA prosthetics to ensure they meet the required standards. In conclusion, my proposed research aims to provide insight into the structural integrity and degradation rate of PLA in 3D printed medical devices. Not only would you be contributing to a better tomorrow for those affected by amputations due to the war, investments in the 3D printed prosthetics will gain interest in purchasing consumable filaments and equipment, which could be a boost in speculated sales and interest in 3D printing in these areas. I hope you give this proposal a thought. Thank you for listening.